Today we will see the moment of inertia depends upon following factors. The moment of inertia depends upon which factors? It depends upon following factors. 1. Mass of the body. If the mass of the body is large, then its moment of inertia is large. Let us suppose that this is a body. If the mass of the body is increased, its moment of inertia is increased. It depends upon distribution of mass. Without changing the axis of rotation, if we change the distribution of mass, then moment of inertia will change. Then third one, position of axis of rotation. If we change the position of axis of rotation from one place to another place, then distances of all particles from the axis of rotation will change. As the distances are changed, the moment of inertia will change. And finally, this fourth factor, moment of inertia depends upon size and shape of the body. If size is the same and shape is changed, then also moment of inertia is changed. If shape is the same and size is changed, then also moment of inertia is changed. So moment of inertia depends upon four factors. 1. Mass of the body. Second one, distribution of mass of the body. As we change the distribution, by remaining the mass same, then also its moment of inertia changes. As we change the distribution of mass of a body, then moment of inertia will change. It depends upon position of axis of rotation. As the position of axis of rotation is changed, the moment of inertia will change. And it depends upon size and shape of the body. So these are the four factors on which moment of inertia is changed. Out of these four factors, if any factor is changed, then there is a change in moment of inertia of the body. Then physical significance of moment of inertia. I is equal to m1 r1 square plus m2 r2 square plus m3 r3 square plus and so on up to mn rn square. So this is the mathematical form of the moment of inertia. It doesn't expresses the meaning of moment of inertia. It gives only the mathematical form of a moment of inertia. So today we will see the physical significance. What is meant by physical significance? So, force in a translational motion is analogous to torque in a rotational motion. The physical quantity force in a translational motion is similar to the torque in a rotational motion. याचा अर्थ ट्रान्सलेशन मोशन मध्ये फोर्स जे काम करतो तेच काम एक्झॅक्टली टॉर्क हे रोटेशनल मोशन मध्ये करत असतो. सो force in a translational motion is analogous to the torque in a rotational motion, and the expressions for force and torque according to Newton's second law of motion are: force is equal to mass into acceleration, so F is equal to m into a. And torque tau is equal to moment of inertia of the body multiplied by angular acceleration. That is, tau is equal to I alpha, where I is the moment of inertia of the body and alpha is the angular acceleration. These two equations are written for same analogous physical quantity. ज्या physical quantity analogous आहेत, साधर्म्य असणारे आहेत, अशा physical quantity साठी आपण हे दोन इक्वेशन्स आले. या दोन इक्वेशन्स मध्ये हे ऍक्सेलरेशन आहे, हेही ऍक्सेलरेशन आहे. हा फोर्स आहे, त्याच्या अॅनालॉगस हा टॉर्क आहे. म्हणजेच या ऍक्सेलरेशनच्या अॅनालॉगस अँग्युलर ऍक्सेलरेशन आहे, म्हणजेच मासच्या अॅनालॉगस मोमेंट ऑफ इनर्शिया आहे. काय म्हणालो मी? मासच्या अॅनालॉगस, मास इन अ ट्रान्सलेशनल मोशन is analogous to the moment of inertia in rotational motion. I repeat sentence once more. So, moment of inertia in a rotational motion is analogous to mass in a translational motion. म्हणजे जो रोल मोमेंट ऑफ एनर्शियाचा रोटेशनल मोशन मध्ये आहे, तोच रोल मासचा ट्रान्सलेशनल मोशन मध्ये आहे. इट मीन्स बोथ प्लेज द सेम रोल इन रिस्पेक्टिव्ह मोशन. ट्रान्सलेशनल मोशन मध्ये मासचा जो रोल आहे, तोच एक्झॅक्टली रोल मोमेंट ऑफ एनर्शियाचा रोटेशनल मोशन मध्ये आहे. मग मासचा रोल काय आहे ट्रान्सलेशन मोशन मध्ये? व्हाईल चेंजिंग द स्टेट ऑफ मोशन, ज्यावेळेस पदार्थाची स्थिती बदलते, म्हणजे पदार्थ हा रेस्ट मधून मोशन मध्ये येतो किंवा मोशन मधून रेस्ट मध्ये येतो, त्यावेळेस ती बॉडी ती स्टेट चेंज करण्यासाठी अपोज करते, आणि जे अपोजिशन आहे त्या अपोजिशनला आपण काय म्हणलेलं आहे? इनर्शिया असं म्हणलेलं आहे. इट इज द अपोजिशन ऑफर्ड बाय द बॉडी when body undergoes a change in a state of translational motion. ट्रान्सलेशनल मोशनच्या चेंज ऑफ स्टेट मध्ये ती बॉडी अपोज करते, आणि त्या अपोजिशनलाच आपण काय म्हणायचं? इनर्शिया असं म्हणायचं. आता हाच पार्ट रोटेशनल मोशन मध्ये काय होतो? when body undergoes a change in a state of rotational motion. म्हणजे एखादी बॉडी फिरायला लागली किंवा एखादी बॉडी स्थिर आहे ती फिरायला लागली, किंवा फिरणारी बॉडी रेस्टला यायला लागली, तर ती फिरणारी बॉडी त्याला अपोज करते, आणि या अपोजिशनला आपण इनर्शिया न म्हणता मोमेंट ऑफ इनर्शिया असं म्हणलेलं आहे. म्हणजे मोमेंट ऑफ इनर्शिया हा कोणत्या मोशन मधला इनर्शिया आहे? मोमेंट ऑफ इनर्शिया हा रोटेशनल मोशन मधला इनर्शिया आहे. म्हणून मोमेंट ऑफ इनर्शियाला रोटेशनल इनर्शिया असं नाव दिलेलं आहे. म्हणजे या फिजिकल सिग्निफिकन्स अर्थ इतकाच आहे की ट्रान्सलेशन मोशन मध्ये मासचा जो रोल आहे, तोच एक्झॅक्ट रोल मोमेंट ऑफ इनर्शियाचा रोटेशनल मोशन मध्ये आहे. हा त्याचा फिजिकल सिग्निफिकन्स आहे. Or it is the opposition offered by the body when body undergoes a change in a state of rotational motion. That opposition is known as a moment of inertia. So the another term in the rotational motion is a radius of gyration. This is a very important concept. This is a very, very important concept, concept of radius of gyration. What is the concept of radius of gyration? It is the distance between the axis of rotation and a point where the total mass of the body is supposed to be concentrated so as to give the same moment of inertia. From this statement, we do not get a clear meaning of radius of gyration. So, I will explain it. Let us suppose this is a body, and when this body undergoes a rotational motion, it opposes, and against this opposition we apply the torque and body is put into rotational motion. So, radius of gyration says that it is the distance between axis of rotation and a point where the total mass of the body is supposed to be concentrated. Let us suppose this is a body of mass m, and when this body is put into rotational motion, its a moment of inertia is I about the given axis of rotation. So, see in this figure, m is the mass of the body and about the given axis, its the moment of inertia is I. Then, remove this body and make it a point mass. या बॉडीचा आपण काय करायचा हा पॉइंट मास करायचा. समजा आपण ह्याचा हा पॉइंट मास केला आणि हा पॉइंट मास या ऍक्सिस ऑफ रोटेशन पासून अशा अंतरावर ठेवा की या पॉइंट मासचा या ऍक्सिस भोवतालचा मोमेंट ऑफ इनर्शिया आणि या बॉडीचा मोमेंट ऑफ इनर्शिया जर सारखा येत असेल तर या ऍक्सिस ऑफ रोटेशनचं ऍक्सिस ऑफ रोटेशन पासून पॉइंट मासचं जे अंतर आहे त्याला आपण रेडियस ऑफ गायरेशन असं म्हणायचं. पहा, बॉडी होती, त्या बॉडीचा आपण पॉइंट मास तयार केला. या बॉडीचा मोमेंट ऑफ इनर्शिया काय होता? आय हा मोमेंट ऑफ इनर्शिया होता. या बॉडीचा मोमेंट ऑफ इनर्शिया, या बॉडीचं मास एम, या बॉडीचा मोमेंट ऑफ इनर्शिया आय होता. या बॉडीचं आपण काय तयार केला? पॉइंट मास तयार केला. हा पॉइंट मास तयार झाला. नंतर या पॉइंट मासचा मोमेंट ऑफ इनर्शिया आपल्याला काही आणता येतो. जवळ ठेवला तर कमी येतो, दूर अंतरावर ठेवला तर जास्त येतो. मग तो अशा अंतरावर पॉइंट मास ठेवायचा आहे की या पॉइंट मासचा या ऍक्सिस भोवतालचा मोमेंट ऑफ इनर्शिया आणि या बॉडीचा मोमेंट ऑफ इनर्शिया हे सेम आले पाहिजेत. त्यावेळेस या पॉइंट मासचं ऍक्सिस ऑफ रोटेशन पासूनचं जे अंतर आहे या अंतराला आपण रेडियस ऑफ गायरेशन असं म्हणायचं. आफ्टर रेडियस ऑफ गायरेशन वी विल सी द फिजिकल सिग्निफिकन्स ऑफ रेडियस ऑफ गायरेशन. What is its meaning? So, moment of inertia can be expressed in terms of radius of gyration. But what is the significance of radius of gyration? Why we have studied such a difficult concept, though we know the formula for moment of inertia? But the fact is that in our previous concept, that is in a concept of moment of inertia, it depends upon so many parameters, factors. It depends upon mass, it depends upon position of axis of rotation, it depends upon distribution of mass, it depends upon size and shape of the body. It means as one of the parameter is changed, the moment of inertia is changed. And it becomes a very difficult to further study. That's why the concept of radius of gyration is used. In the concept of radius of gyration, parameters are reduced. Parameters are reduced. First benefit of concept of radius of gyration is that in the concept of radius of gyration, formula for mi for all types of bodies is I is equal to mk square. That is, formula is the same for all types of bodies. Body may be regular, body may be irregular, body may be linear, one-dimensional, two-dimensional, three-dimensional, or whatever may be the size and shape of the body. For all types of bodies, formula is same. Formula is same. So, I is equal to mk square. In the previous concept, as the size is changed, formula is changed. Shape is changed, formula is changed. But in this concept, as long as the radius of gyration is the same, the moment of inertia of the body is the same. Then radius of gyration depends upon what factors? Here there is only one factor. The radius of gyration depends upon distribution of mass only. This is a single factor on which the radius of gyration is dependent. As long as the distribution of mass is the same, the radius of gyration will be same. If we take a disk and the radius of gyration of the disk is, let us suppose that the radius of gyration is 10 centimeter. If we keep another identical disk on that disk, the radius of gyration of two disks will be 10 centimeter only. Though the mass is changed, radius of gyration will not change. Because the distribution of mass is same, that's why radius of gyration is the same. If we put 2, 3, 4, 5 disks, then also the radius of gyration is the same. It means radius of gyration do not depend upon mass. It only depends upon the distribution of mass. As long as the distribution of mass is the same, radius of gyration will be the same. So this is the strongest point of the concept of radius of gyration. And if the distribution of mass is closer to the axis of rotation, distribution of mass is closer to the axis of rotation, then its radius of gyration will be small. Moment of inertia will be small. If the distribution of mass is away from the axis of rotation, then its radius of gyration will be large, and as its radius of gyration is large, its moment of inertia will be large. As in this example, if suppose this is a rod, this part is of wood and this part is of steel. If we rotate about this axis of rotation, heavier part is away from the axis of rotation. So distribution of mass is away from the axis of rotation. So moment of inertia will be large. If the rod is put in this direction, that is, a heavier part is closer to the axis of rotation. So distribution of mass will be closer to the axis of rotation. So radius of gyration will be small, and its moment of inertia is also small. So this is the concept of radius of gyration, in which we decreases the parameters on which the moment of inertia is dependent. Okay.